All right. Hello, and thank you for watching. I discovered, well, first of all, I made some changes, as you can see from the previous um, video that I made. Right now, I'm putting all these wires, as you can see them right now, uh, a bit unorthodox, but it is they are reflecting pretty much how it will be in reality. It's close enough. It's not perfect, but it's close enough as it will be in reality. In reality, it will be wires. I mentioned already, but I will say it again. Copper wires soldered from the pins to the pads on the cardboard that I will make. So from the pins of the chip, I see. Okay, this is the wires thing, and I really wished I modeled everything in Proteus here. Uh, in the last part, I made already the tests with the real chips. I solved the problems. Actually, not me personally, but I got some help uh, uh, solving those problems, and I cannot thank them enough to those guys from AAC forums. And I lost my idea. uh, so what I want to say was that yes, I made the first tests on the real chips. I figured it out the the problems, how to link everything, also with some help. And after all of that, after I made all of these three real, in reality, chips, I jumped here in Proteus and I start modeling everything. For the only reason was to see how it will may look as close as possible as I can, because in the end this is a simulator and it's very easy and fast to cut and paste and modify very extremely quickly in a matter of seconds the entire board, pretty much, or the entire area, and then copy paste it. While in reality, if I have to do it with paper and crayon on paper, it's a bit more complicated. So that's why I'm getting into Proteus for this particular reason, this very important reason for me at least, designing the board pretty much. The second reason I started Proteus was but this was not absolutely necessary. But I tried to see if it's possible, and it turned out it was possible, which is great. It's absolutely great. So I wanted to also simulate the circuit to see it actually work, and it did exactly that. It did worked, and it's fantastic. Let me show you. I loaded a program that this is the program that I run in the reality, on the chips on reality. All three chips are only port B here. Only this side of the chip is it, it appears if I'm moving the mouse the thing is not working. If I leave it still, it is working. Okay, so only port B is activated because that was the setup that I had in reality, and And then let's stop this and let's load the I can show you actually. These are my all the test programs that I made using let me very quickly show you how I made a hex file in Arduino. So I have already the program here, whatever it is, doesn't matter. I go to Sketch and then export compile binary. If I'm clicking this guy, actually I can click it again. You have to wait a couple of seconds, and it's already done, and that's it. And after I created it here, is created. I just simply drag it here, copy it here, overwrite it this time. But I'm copying in this side of the on this very short root that I have on C0, a folder 0. I made a folder named 0 in C drive to be able to get it very quickly. What is this? To be able to get to it very quickly. So now that was port B only. This was in reality the testing program that I used in reality, and it's also simulated perfectly here in Proteus as well. This I didn't put it tested in reality. Actually, all the ports, all the pins, and okay, and is behaving perfectly here in Proteus. Again, if I'm moving the mouse, is a gap. So we will follow all the LEDs, and all the LEDs are finishing doing what they are doing, and it's working excellent. Okay, another very important part. So I stop the program right now. Right, let me get back here on add pin. I remade this little circuit schematic. Not just schematic. How is it called? Table, circuit table. So for the logic pins, for these 3 logic pins here, where are they? 5. No, it doesn't. So for A0, A1, and A2, these links here. Before it was 3.3 volts, and I thought I have to. Well, I reached the point in my design here to add the high, the logic high, and the previous table that I had, it was from, of course, from internet. Other guys helped me with it actually, finding it for me, and in it was specified 3.3 volts. And I discussed this problem with the guys, and with the guy actually, one single guy responded to me, and he made it clear enough that the logic high is equal with the voltage that the chip is powered with. So if the chip is powered with 5 volts, the logic high will be 5 volts. If the chip will be powered with 3 volts, the logic high will be also as 3 volts. That's why it was 3.3 volts back then. So now I modified the entire table here. I put in my 5 volts that I usually use for the large majority of chips that I'm using. I never or extremely rarely use chips at higher voltages or lower voltages than 5 volts. Usually is the 95% of the cases I'm using 5 volts for all the chips I'm using. and it's perfectly safe, perfectly fine. Everything is working as it should be. I'm not using extravagant ICs, although this is an extravagant IC as well, but is in this limit of 5 volts. Actually, it's maximum. It's 5.5 volts is maximum voltage that is operating. Otherwise, it will be burn in flames of hell. And yes, this is it. This is what I wanted to add more. This is the update pretty much of the circuit, and this is simplifying a lot the circuit, because if I was doing it as I was believing in the beginning, that I really have to add only 3.3 volts, and I had to build a dedicated voltage regulator to lower down the voltage to 3.3 volts, and from there I had to drag the wires to the respective pins to create that logic high for each specific pin, as it should be, as the table is telling us to link. But this time is simplifying a ton everything, because now I can link it to 5 volts, which is this this line here. It doesn't get red because it's having these points here. So this is the 5 volts that is linked to all its reset pins, and from the logic pins here, 0, 1, 2, I link it directly to this reset, which is already linked to plus, to 5 volts, and problem absolutely solved. And I escaped with from a problem, which was a problem to solve, and it was creating more stuff on the board, you know, more wires, especially more wires to drag to each logic pin, and already it is very complicated from the wires perspective. And imagine I have to put 8 of them. For now is only 3, but yeah. And it's working absolutely perfectly, and I think I will stop here. I'm not sure if I will actually make all of them, or 8 of them. I'm not sure. Here in Proteus, I mean. It's working perfectly fine until here. The program is working. The link, the wires that I link everything are okay. I'm happy with them, and shit. I lost my train of thoughts. So pretty much I'm happy with everything that I have here. The wires, especially how they will look on the final board. Look how beautiful they are, changing color. But yes, this is pretty much how it will look. So I think I will close. I don't have anything more to add. Alright, thank you very much for watching until now, until here. And yeah, I think I should start building the real thing and make the update with it next in the next video. Because this is step by step, everything that you see here, as you already figured it out. Alright, thank you very much, and see you later. Bye bye.